Understand the nature of bonding and structure in ionic solids. Ionic solids are held together by strong, highly directional electrostatic attractions, ionic bonds, between alternating cations, positive ions, and anions, negative ions, arranged in a three-dimensional crystal lattice. In a stable ionic lattice, each positive ion is surrounded by negative ions, and each negative ion is surrounded by positive ions, maximizing attractive forces and minimizing repulsive forces. Analyze what happens when an external force is applied, displacement. When an ionic crystal is subjected to mechanical stress, such as being struck with a hammer, a plane of ions is forced to slide or displace relative to the adjacent plane. Determine the electrostatic consequence of this displacement. Shifting a layer of the crystal by even a single ionic diameter causes ions of like charges to align directly across from one another, i.e., positive ions align with positive ions, and negative ions align with negative ions. Relate this charge alignment to cleavage and brittleness. Because like charges repel, the sudden alignment of positive and negative charges results in massive electrostatic repulsion between the two adjacent layers. This repulsive force instantaneously drives the layers apart, causing the crystal to split cleanly along a flat plane, known as cleavage, and shatter, which represents the property of brittleness. Identify the correct diagram. Diagram perfectly illustrates this physical mechanism. The before displacement view shows a stable alternating grid of positive and negative charges. The after displacement view shows that the applied force has shifted the top layer, aligning like charges, plus next to plus, and next to directly opposite each other, driving the layers apart and creating a cleavage gap. The correct answer is option A. Visual.